Our planet has a pulse, a rhythm of ice and fire that beats over millions of years. We live in a warm, stable interlude. But stability on Earth is the exception, not the rule. Because deep in the rock record, geologists found evidence of a planetary fever so extreme, it defied belief. A time when the entire world, from pole to pole, turned into a single, lifeless ball of ice. This wasn't an ice age, this was planetary cardiac arrest. In the 1990s, a scientist named Paul Hoffman made a heretical claim. He found glacial debris, rocks scarred by mile-thick ice, in Namibia, a place that sat near the equator 700 million years ago. His conclusion was terrifyingly simple. The ice didn't stop at the poles, it didn't stop at the tropics, it kept going, until the entire planet was encased in a shell of ice over a kilometer thick. They called it Snowball Earth. Here was the paradox. Once ice reached a critical latitude, it reflected sunlight back into space. The planet cooled further, creating more ice. A runaway refrigerator effect. Models showed that once triggered, Earth could plunge into a deep freeze in under 1,000 years. And escape? That seemed mathematically impossible. If Snowball Earth was real, how did life survive? How did the thaw even begin? The answer lies in a planetary suicide attempt and a volcanic resurrection. The evidence isn't just ice scars, it's in the rock that immediately follows. Worldwide, atop the glacial deposits, lies a bizarre layer of limestone called cap carbonates. These formed rapidly in warm, alkaline oceans. It's a chemical signature of a planet going into shock, as if Earth, after its frozen nightmare, vomited carbonate into its seas. This is the geological equivalent of a fever breaking. And once again, we confront the void. The periods just before the freeze, the cryogenian era, are poorly preserved. Did life flourish in a warm world before the ice? Were there complex, perhaps even multicellular organisms that were utterly erased by the freeze? Their fossil record, if it ever existed, was likely ground to dust by continental glaciers. Another missing chapter. Then the plot thickens. After the thaw, something unprecedented happens. Oxygen levels in the atmosphere double. This is the Great Oxygenation Event 2.0. And with it, in the fossil record, we see the first undeniable explosion of complex life, the Ediacaran biota. Strange, soft-bodied creatures that look like nothing before or since. The sequence is too perfect. Global freeze, sudden thaw, oxygen spike, life explodes. Coincidence? Or is this the story of a planet nearly dying, only to wake up stronger? Let's play it out. Earth is a snowball. Volcanoes, however, don't stop. For millions of years, they pump CO into the atmosphere with no oceans to absorb it. The greenhouse gas builds to absurd levels, hundreds of times today. Then, a tipping point. The ice begins to melt, and once it starts, it collapses in a geological instant. The thaw would be apocalyptic. Hurricanes of steam, rains of acid, temperatures soaring to 50 C globally. This was not a gentle recovery. This was a planetary fever dream. And in that fever, new chemistry was born. Snowball Earth is not an ancient curiosity. It is a stress test of the Gaia hypothesis, the idea that life regulates the planet. Life failed the test. The freeze nearly wiped it out. But in doing so, it set the stage for a revolution. This is the ultimate horror and hope, that our planet's stability is fragile, but its resilience is monstrous. It asks us, is climate change a crisis? Or is it just Earth's normal, violent rhythm, a rhythm that has zero regard for the tenants living on its surface? So, did Snowball Earth happen? The rock screams yes. But the deeper question is, why did it happen at all? And is it our future? We think of ice ages as slow encroachments. Snowball Earth teaches us that climate can tip into abyss in a geological heartbeat. It suggests that life's greatest leaps might be born not from stability, but from catastrophe. We worry about leaving a scar on the planet, but the planet bears scars far deeper than any we can make. Our true challenge isn't to avoid changing the Earth, it's to survive the changes that Earth has already planned for itself.
The planet remembers what we forget. We're just the latest chapter. Subscribe to understand the planet we're living on.